Right, hello everyone, welcome to another video. As you can probably tell by the sound of my voice, I'm a little bit annoyed with myself because I've just been working on this device and it's a rather interesting device, but unfortunately I didn't have any audio. So I've just gone through half of my diagnosis process on this without recording any audio, which means the footage is pretty much unusable. So the device we're looking at today is this, well, what's it called? I forgot now. So the device that we're looking at is called an airflow meter. So basically what this is it's been sent by a air conditioning company, and it measures the flow of air conditioning units. So when they got in touch with me, they said that basically one of their staff had plugged in the wrong power device, or the wrong power cable rather, and they'd blown something. So what they did was they took it apart to see if they could see it. The person who, I think he's a manager or he owns a company, I'm not sure, he watches my videos and he's fairly competent. He's not stupid. He knows how to fault find and stuff. But unfortunately, when he hooked up a thermal camera to this, he basically couldn't see anything because the thermal camera that he's got isn't very good. He's only got a FLIR handheld camera, which is mainly used for measuring the heat on things like pipes and things like that. So he sent it to me to try and fix, and basically I've done a little bit of fault finding myself. Essentially what I've done, and I'm not going to do it again, but I'll use the footage that I've already captured and just voice over from here. Essentially what I've done is I've connected up the thermal camera, my own thermal camera, the Infrared P2 Pro, which is a fantastic camera by the way, and I highly recommend getting one if you do component level repair. I'll leave a link in the top pinned comment. But basically what I've found so far is there's a few components which are getting hot. I've used the macro lens, which allows me to identify components much closer and in much more detail than, for example, a normal thermal camera would. So I've managed to identify 3 components which are potentially faulty here, but I don't know if there's going to be anything that I can do with them. So the components that I've identified are these 2 here and this one here. So there's a bunch of 3 components, and I've also identified on the back of the board where the battery plugs in, there is a pinout. Well, there's some indicators to what goes where on the silk screen, and the fuse is good, but we've got a short on the 3.3 volt line. And basically that, from what I can tell, goes to these 3 components. Now these components, this here is a clock chip. So basically the part number for this, if I just have a look here, the part number for this is M41T11, which is serial real-time clock with 56 bytes of NV RAM. It's made by ST Microelectronics. And basically it's just a clock chip, real-time clock, right? Hence the fact that there's a battery on this as well, because I assume it needs a battery to store the clock. The other thing, if I just pull up the information for that, is 45PE80, again made by ST Microelectronics. ST Microelectronics. So if we look for the data sheet for that, you'll see here it is 8 megabit low voltage page erasable serial flash memory. Now I can get these components, they're off the shelf parts. The problem is going to be whether or not I can read one of these components. If it is, for example, one of these, if it's this, that shouldn't be an issue. I can order one. If it's one of these, I need to be able to read it, because it's going to have custom firmware on there which I am not going to be able to get access to unless I actually dump the firmware off the chip. Now, dumping the firmware isn't really an issue. I can use, a standard run-of-the-mill CH341 programmer, or I should be able to. The problem is going to be whether or not these chips work enough to be able to dump the firmware. So yeah, that's basically where I'm up to. I've also tested some components around here, and we've got a short on the middle 2 pins at the top on both of these. So basically, that, from what I can tell, I haven't looked at the diagram for it, but that, from what I can tell, is probably 3.3 volt input to these chips, and the other pin is probably ground because there's a short on both pins. So yeah, that's pretty much where I'm up to. I'm sorry it's not the normal format video, but hey ho, these things happen, and I do want to make a video on this because it is quite interesting. But anyway, for those of you that don't know me, my name's Hakko. I'm an electronics technician. I mainly work on games consoles, but I do dabble in other stuff too. So if that's the sort of stuff you're into, be sure to get subscribed, turn on the bell notifications, and that way you don't miss any future videos. And also a word from today's sponsor, PCBWay. PCBWay are currently celebrating their 10th anniversary, and golly gosh, they're doing it in style. As a special thank you, PCBWay have decided to extend their anniversary sale until the 31st of August 2024. With massive discounts of up to $240 off your order, you can get your next project started today. But did you know, PCBWay don't just offer PCB fabrication services. They also offer flexible PCBs, 3D printing, CNC machining, and much, much more. I'll have the website link below, so be sure to check them out and get your limited time discounts. Let's get back to the video. So, under the scope then, if we look on this side of the board, you can see we've got some information on the silk screen. So we've got the data lines, we've got VBAT, all of these are all good. The only one that's showing us short is 3.3 volts. And again, voice over here, but when I injected voltage, I basically injected into the 3.3 volt line. Nothing was turning on until I actually gave it 3.3 volts. So I gave it the 3.3 volts, and lo and behold, these components here were getting hot again. So yeah, what I'm going to do, it does stand a chance that it could be a capacitor, but it's very unlikely. So I'm going to go ahead and I'm going to remove the left-hand chip here first. In fact, no, I'm going to remove the real-time clock first. I'll change my mind. I'm going to remove the real-time clock, and then I'm going to see if that 3.3 volt short is still there. So this is a really thin board. It's a very basic board. So what I'm going to do is I'm going to drop my airflow down. I typically go for around about 420, 440 degrees Celsius. But I'm working with a completely unknown board. So I'm going to go to 380 degrees Celsius. And that's probably going to be plenty to remove this chip. Solder melts at 217 degrees Celsius. And yep, just like I suspected, it's absolutely more than enough to remove it. So yeah, the solder melts at 217, so we usually go a bit higher because hot air is sporadic. But yeah, let's remove that. Let's pop that to one side for a minute. So that's the real-time clock. Now what I'm going to do is I'm going to check these lines again. So I found a short on the capacitors above these two chips. So let's have a look again. So for ground, I'm using this shield just here. It is a common ground. So there's a shield just here I'm using. So as you can see, we do have this in beat mode. Let's have a look on these again. And yep, that one is still short. And so is that one. In resistance mode, what do we get in resistance here? 45 ohms. Okay, that's a bit strange. 45 ohms. I don't know if that's going to be normal, to be honest. Let's remove these other two components one by one. It's a 3.3 volt line. I would imagine 45 ohms is way too low. Damn it. Well, that didn't exactly go to plan, did it? Okay, I managed to get it off though. Don't worry about those. In fact, yeah, let's worry about those. Let's pop those back. I'll pop a bit of flux on those. Just a tad. Just make sure that those are actually soldered because I don't want to skew any results. And let's test again. So in continuity mode. We no longer have a short. So this side looks like it is ground. This one is not. This one is not short anymore. So let's just have a look at this component here. Actually, let's solder this back on first. This chip that I've just taken off. Before I end up losing it. Okay. Keep this as clean as I can and use as little flux as I possibly can because I don't want to cause this to go out of calibration or anything like that. Alright, there we go. So that's that. So now the question really is this going to work with just one of those chips on? Is one of those a backup? So what I'm thinking is maybe, because this has got an RS232 port on it, so what I'm thinking is maybe when you update the firmware on this over serial, does it back the firmware up onto a secondary chip and then right to the main chip? You know, does it give itself some sort of a failsafe? I really don't know. So I am going to hope for the best and hope that the firmware is the same on both of those. Now, I don't know the diagram at all. Which way are we looking here? That way. And it's the middle two pins. So, do we have a short on this component on the middle two pins? Huh. Apparently we don't. Or is it that resistance has increased on the board and now it's not beeping at me? What is the actual resistance on this? Let's have a look. Am I being lied to by the board? Let's see. 45 ohms. Okay, so that chip wasn't bad. Either the chip's not bad or it's not that chip. It could be the second one. Let's just let's remove this one. Right, what is my resistance now? See, this is why you should always check resistance as well. That's a ground pad. 49 ohms. So it's not that. So what on earth? Why is this 49 ohms on a 3.3 volt line? Doesn't make any sense to me. Let's see, do we still get the same behaviour? So the behaviour that I was getting with this was when I applied power to it, we were getting a couple of green lights. Yeah, we do. So it is still at least attempting to power on without those chips on there. Right, so now here's the question then. Does anything get hot? Because those components were what we're getting hot, right? So is anything going to get hot without those on the board? Okay, that's fairly warm. I'm going to need to let the board cool down a bit more though. Oh, that's way too warm. Okay, I am going to let the board cool down. Just sprayed a bit of IPA on it just to bring the temperature down a little bit. Let's have a look again. Let's see what the deal is. Oh yeah, that's definitely getting hot. (38°C). Oh, hang on a minute. Oh, it's fried the CPU, hasn't it? It's got to have done. Oh wow, that's a very specific heat spot. Any more heat spots? We've got the real-time clock chip. Nah, nothing. Well, that's a... Oh, hold on. Hold on a minute. That there. Wait, that's a resistor. What the? So here's that component which was getting hot. That's directly underneath the CPU. Or, well, the microprocessor. So... theoretically, it could be one of these caps around here. Well, that's going to 61 ohms. That's 10k. Sorry, C301 is 10k. C300 is 61 ohms. Is that bad? Like, is that capacitor bad? Let's remove that. So what I can do is I can just pull this out of circuit. So if I just push that like that and just leave it, well, basically only connected on one side. Check it again. No, 67 ohms. It's not that. Okay, leave that one out of circuit. So this side, 45 ohms. This side is open line. Okay, so what I can do now then is I can inject voltage just into, in fact, let's just check this 3.3 volt rail again. So let me just have a look at my resistance here. 45 ohms. Yeah, see, that would, to me, that's low, like real low. So what I can do now though is I can inject, well, I don't need to inject voltage, I can just use the batteries. So I can use the batteries and I can basically use the thermal camera and just see if anything's getting hot now. And yes, I know you can see the thermal camera on the screen here. It's crashed because it's not connected. It's fine. As soon as I reconnect this, it should reconnect on the PC. There we go. So we've got a little bit of a spread heat there. So let's just pull that down a little bit. No, I'm gonna have to give it a minute. Okay, fine. Alright, let's give it a whirl. See if I can see anything. Not really. We've got a heat spot here. That component there again. Oh. And through that inductor. Okay, there's a component just next to the inductor. What is that component? Is it a cap or is it a fuse? It looks like a cap and it don't look great. Let's check it in resistance mode. Dead short that side. 2 million ohms that side. It's not that. What about this cap here? Dead short that side. 590,000 ohms that side. What about the inductor? 40 ohms. 4 million ohms that side. Huh. No, 40 ohms, okay. Just a contact issue. It's a little bit difficult to keep on camera, but yeah, 40 ohms both sides of that, okay. So, I'm isolating a lot of circuits here, but let's just isolate this one. So this one's a bit more difficult to do, so I'm going to take the nozzle off. Okay, so I've removed that inductor. So we've got 40 ohms, well, we had 40 ohms on both sides of this. Let's see which side we get 40 ohms on now. Is it going to be any different? 130 ohms there, but that is dropping. Dead short there. What? That's climbing. Right, is that connected to the 3.3 volt line? We've got 50 ohms of resistance to that. Okay, the board is way too hot at the minute. Right, so I've just checked again and we're getting 400 ohms on this bottom one here at the minute. Hey, you can't read it now. This side has no problem reading, 44 ohms. This side is not giving me a reading. You can't decide whether it's over 5,000 ohms or not. It might just be too hot. Let's just spray some IPA around here. It just cools it down a bit. Yeah, it still can't decide. The multimeter's just not making up its mind at all. But this side it is. So I'm going to inject into this rail again. So what I'm going to do is I'm going to inject into the top of here. So I'm going to pop some leaded solder down. Just like that. I've got to put leaded solder on anyway to re-solder the inductor on. So what I can do is, rather than messing around, I can just solder a wire straight to here. So an inductor is never going to be connected to ground. So we'll pop that wire there, and we'll pop ground back on here like I did earlier on. Doesn't have to be a great connection. Okay, that'll do. Doesn't have to be perfect. So we get 180 milliamps of current draw now, and whoops. Yeah, everything is lighting up apart from obviously these are not connected up, and we've got a resistor isolated as well. Let's pop back under the thermal camera and see if anything else is getting warm. In fact, let's just have a look. That's not getting warm now. Or it doesn't feel like it is. Right, give that a minute to reset. There we go. Okay. No hotspots. Interesting. Or at least none immediately obvious. That's the inductor I've just removed. We've got a hotspot there which is ground. Hello? Stop crashing. So it looks like all of the heat is being pulled to ground now. Oh. Still that component there getting warm though. Got some heat underneath here. There's nothing under there. It's all ground points. They're getting warm. They're ground points which are getting warm. Still that component there, it's a clock chip. That's the real-time clock chip. I'm not sure what to do with this, to be honest. It could be the real-time clock chip. I'll tell you what. No, nothing's happening there. Let's just disconnect power a second. What I'm going to do, I'm going to resolder these two components here, and I'm going to reconnect this resistor as well. So there's that resistor that I partially disconnected. Okay, there's that. I did keep these in order so I know which one goes where. Okay, so partially flow those down, and then I'll add a little bit of flux here. And that one didn't partially flow down at all. That's nice. If you hear any sizzling on the microphone, it's just IPA. So there's IPA still on the board, and that's obviously evaporating. I'm going to drop my nozzle on just to get some finer rework. That's more like it. Okay, let's give that a few minutes to cool down. Okay, back to business. Let's pop it under the scope again. Sorry, under the thermal cam, not the scope. So, at the minute, it's a little bit warm, so I'm just going to blast it with some IPA again. There we go. How's it looking? So, it's a little bit warm, but it's fine. Let's just pop 3.3 volts into it. We get 242 milliamps of current draw. So we're getting less current draw with that inductor off. However, that CPU definitely gets warm. I think it could be the CPU. You could have fried it. Maybe it sent God knows how many volts straight through to it. If it's CPU, it's going to have custom firmware on that. You're never going to get that. Or at least I wouldn't. That thing still gets hot. However, those two components there don't, interestingly. So this thing is still getting hot. This real-time clock. These two components here, this flash memory isn't. Is anything on the back getting warm? Not really, no. These resistors, so there's a fair bit of heat going through, and that is directly underneath the CPU. So there's a fair bit of heat going through that. One thing I am going to do real quick is just connect up this LCD. I'm just seeing if the LCD is actually going to turn on, but it's probably not. So we have the LEDs on. No. No, I honestly don't think there's going to be anything I can do with this. I'll get rid of that thermal camera image. Yeah, I don't think there's going to be anything I can do with this, to be honest. I personally think that, given where the heat spot is, there's a fair bit of current going through that resistor. I'm going to say it's probably sent too much voltage to the CPU, and that's something I hate saying because I don't know. But I just don't think there's going to be anything that I can personally do with it because, well, yeah, I don't think I'm going to be able to get the parts for it, which is unfortunate. It would have been nice to be able to fix these. These are pretty expensive devices, as far as I'm aware, but it is what it is. There's not a lot you can do about it. If it is the CPU, I'm not going to be able to get the software. I could go out on a whim and buy a real-time clock chip, but the problem with that is, number one, it still gets warm on different parts of the board without the real-time clock chip, and number two, I'm going to be buying parts based on a whim. So yeah, it is unfortunate. I mean, I'm more than happy if the customer wants to actually order them, but they would have to pay for them, right? I can't buy them not knowing for sure whether it's going to be the issue or not. So yeah, unfortunately, this is going to end in a no fix. That's just the way it goes in real life. Not everything's peaches and creams, and yeah, not everything is fixable. At least not for me. Let me know what you think. Have you ever seen one of these? Have you ever worked on one? Do you know what else it could possibly be? Because, to be quite honest, I'm clueless. Yeah, never mind. Thank you for watching. I really appreciate it. If you do have any comments or questions, leave them down in the comment section down below. As always, don't forget to subscribe if you are new to the channel, turn on the bell notifications, and give the video a thumbs up as well. And if you do want to support me, I do have a Patreon as well, so you can check me out over there, patreon.com/thecoder. Yeah, that's going to be pretty much it. Thank you for watching, and I'll see you all in the next video. Take care, everyone. Bye for now.